All right, this is exam review for chapter 6. Starting with 6.1, rate of change, which we now know, of course, as we've moved past this chapter, is slope. But looking specifically at rate of change and not necessarily using the term slope just quite yet. The chart on the right shows the weight of Anthony's golden retriever as time passes. Clearly, it gets heavier and bigger as time passes. We're going to calculate the rate of change between week 8 and week 20. So we are specifically looking at what was the rate of change between these two marks right here, week 8 and week 20. Now think about when you answer this question, you're going to be talking about how much it's changed per something. That's what a rate of change sounds like, per something. So just looking at the two units, are we looking at how many weeks per pound? Or is it better to express the rate of change as how many pounds per week? Pounds per week is going to be the better unit here. Okay, so we want pounds per week. When we set up our ratio, we need to have it reading from top to bottom in the correct order. So pounds per week. So what we're going to do is we're going to figure out how much the weight changed in pounds, how many weeks have passed, and then we quantify that all down to just one number. So we're going to put pounds on top. So the pounds went from 39 to 10. So we need to know what was the difference? How much did it change? So 39 minus 10 will give us that number. And maybe you just jumped straight to the 29. That's fine. And then that was over 12 weeks, and that comes from 20 minus 8. So the pounds went from 10 to 39. So that was a change of 29 pounds. And if you want to put LB for pounds, that's fine. And then on the bottom, the weeks, we minus 20 minus 8, that is over 12 weeks. So of course it's not going to be perfectly consistent, but we know that there was 29 pounds gained over the course of 12 weeks. And so we're going to go ahead and divide those and get a number to represent that. And that's going to be how many pounds per week. So 29 divided by 12 is 2.416 repeated. So we're going to go 2.416 repeated. And that is pounds per week. So on average, the increase was pretty much close to 2.5 pounds that it increased every single week. All right, so then in 6.2, now we start looking at rate of change as the slope of a line and actually putting those two things together. So it says find the slope of a line graphed on the right. So a couple of options. When you have a graph, you can count boxes, and we do need to be careful and make sure that we're looking at the units that each box represents. So you can't just count the boxes, we have to count the units, but we can do rise over run. And so we can use the graph to do it that way. Or you can also just look at the coordinates and use them with the slope formula. And so if you looked at the answer key, it went straight to the slope formula. So if you need to see that, you can see you've got your x1, y1, x2, y2. Those came directly from the points on the graph. And then slope is the change in y, which is the rise, because y goes up and down, over the run, which is the side-to-side change, which is our x values on a graph. So 10 minus 7 was right up here. 15 minus negative 3 was right down here. And we're going to get more into the slope formula in just a minute, so I'm not going to spend too much time going over the specifics. But you solve that out, and then there's your slope. But I want to look at it as something we can do on the graph first. So the rise is the change in the y value, basically. It went up. Now, if you try to count boxes, it's a little bit difficult because these boxes are counting by twos. But if you look at the y value, it was at 7, right? Here's 7. And it goes all the way up to 10. So the rise, the change there, was 3. And the x value was at negative 3, and it ends up at 15. And so how far is that? Now, I'm not just counting boxes. Just think about it, and I would just do it in jumps. From negative 3 to 0, that's a distance of 3. And from 0 to 15, that's a distance of 15. So the total distance of change here, the amount of change here, 3 and 15 is 18. So the rise was 3, the run was 18. We always simplify. And so you divide these both by 3, and that's 1 over 6. So positive slope, everything's from left to right. Just like you read the words, follow the letters from left to right. Positive slope means it's increasing from left to right. A negative slope means it's decreasing from left to right. An undefined slope is a measurement that we can't actually quantify. So that's when a line goes straight up and down, because you can't get a number that represents how fast that's rising, how fast that's falling. A zero slope is the opposite, kind of. But we can put a number to this. It is not rising. It is not falling. The slope is 0, right in the middle. This is either rising or falling. It's hard to figure out which, depending on which way you're going on the line, right? And so we can't define this slope. And of course, if we set up our slope formula, this comes from trying to divide by 0. So that doesn't work. All right, so now we're going to go ahead and calculate the slope between the given points. So now we're going to use that slope formula, which is y2 minus y1 over x2 minus x1. Remember, whenever we're doing subtraction, we're finding the difference between the numbers. So we're finding the difference between the y's, how much they changed. We're finding the difference between the x's, how much they changed. So it doesn't matter which way you go, you have to be consistent. So I always just take a quick glance at the numbers, and if there's a consistent way to subtract that will give me all positive answers, then I'm going to go that direction. And when I see this, I look at my y, and my y, if I go this direction, 23 minus 11, I get a positive number. If I do 9 minus 5, I get a positive number. But you could go the other way, 11 minus 23 and 5 minus 9. Those would both produce negatives. So you'd have a negative on the top and a negative on the bottom, which would end up canceling, and they do give you the same answer. So it doesn't matter which way you go, you have to be consistent. In the end, you'll get the same answer, but you got to be careful. If I go this way with the y's, I have to follow suit and go that way with the x's. I can't change it up from the top to the bottom. Okay, here, so I'm going to do 23 minus 11, and that's 12, and 9 minus 5, and that's 4. And that simplifies to a whole number of 3. So we have a positive slope of 3. Over here, subtract my y's, 8 minus 3, subtract my x's. Now I went this direction, so I got to go this direction. Negative 6 minus 4. So I'm going to get 5 on the top. Negative 6 minus 4 is negative 10. So only one of these is negative, right? The 5 is positive, which means my final answer, if one of them is negative, my answer is negative. If both of them are negative, my answer would be positive. So negative, and I simplify 5 over 10 to 1 half. So it's a slope of negative 1 half. All right, moving on to 6.3. We're going to put these lines just from the information given on the graph. So we're graph the line that passes through point 2, 3. So first, looking at my graph, I double check and make sure my boxes are counting by ones, and they are. So 2, 3. Remember, it's always x and y. So 2, 3, 2 on my x, 3 on my y is right here. It has a slope of negative 2. Okay, the whole number. So express it as a fraction. Remember, this is the rise and this is the run. So negative means going down 2 and then going over 1. And remember, think about how you follow letters when you're reading left to right, and that's what we're doing here. So when we go down 2, we have to go to the right one. Down 2 to the right one. Down 2 to the right one. And if I'm going to follow this line the other direction, going this way, it's up 2 into this side to the left 1 to continue that line. And as I follow that line from left to right, it is going down, and that's the negative slope. So graph the line that passes through negative 4, 5. So negative 4, 5, a slope of 0. That means it's not increasing or decreasing. So it is going to be a horizontal line like this. And then graph the line that passes through negative 2, negative 6, has a slope of 1 over 4, positive 1 over 4. So this is my rise and this is my run. So since it's positive, I'm going up 1 and then always to the right 4. 1, 2, 3, 4, up 1, 1, 2, 3, 4, up 1, 4. And if I was going to try and follow this backwards, I'd do the opposite. Down 1, 1, 2, 3, 4 to the left. Down 1, 1, 2, 4 to the left. All right. 6.4. What is the formula for slope-intercept form of a line? So that is our y equals mx plus b, because this is my slope and this is my intercept. The name tells you what the equation identifies, slope and intercept. So write the equations below in this form. So what's special about this form is that the y has been isolated and everything else is on the other side. So we have to rearrange these equations so it looks like this. Basically just get y by itself, solve for y, and then after we can identify the slope and the y-intercept. So starting here, if I want to get y by itself, the first thing I do is move the term with the x to get it on the other side. The 12 and the 3x are not similar, so they're not like terms. We can't put them together. They stay separate. So it's 4y, and it's going to be negative 3x plus 12. I minus the 3x, so it's negative. 12 is positive, so it's plus. If you wanted to write 12 minus 3x, that's fine too. I'm just going to keep it in this kind of standard form with the x up front, but there's nothing wrong with writing 12 minus 3x. And then we're going to divide by 4. Everything divided by 4 when we do that. So this cancels, leaving me y equals, which is what I wanted. 3 and 4 are not going to divide nicely. You don't need to make it a decimal. Leave it a fraction. It's negative 3/4 x. That's our slope. And 12 over 4 is positive 3, so we're good there. So slope is negative 3/4. Y-intercept is 3. Okay, next, we got to get y by itself here. So I'm minus x. I still have a negative y. That minus has to stay. I'm going to put the x up front. I can't combine it with the 7, so it's negative x minus 7. And I can't leave this as a negative y, so I'm going to divide by negative 1. Everything divided by negative 1, which just changes the sign. And so it's no longer going to be negatives. They're all going to be positives. So y becomes positive, x becomes positive, 7 becomes positive. Okay, this is good form. And I can identify my slope and my intercept. Slope is the coefficient to x, it's 1. And my y-intercept is 7. All right, last one, get y by itself. So subtract the term with the x in it. I'm going to put it up front, negative 8x plus 18. Divide by 2. Everything divided by 2. Y is now isolated. Negative 8 divided by 2 is negative 4x. 18 divided by 2 is positive 9. So there is my slope-intercept form with the slope being negative 4 and the intercept being positive 9. All right. Moving on to 6.5. So now we're looking at point slope form. So this is y minus y1 equals mx minus x1. Again, the name means it gives me a point and a slope. So my point comes from this, and my slope, of course, is m. The tricky thing with this, if you remember back, is that the equation actually says minus. So when you see a number here with a minus, a lot of times we think, oh, that's a negative. But in this format, it's supposed to say minus. So if I plug in a positive number, it still says minus. And so if we see an equation with y minus something, this is actually when I talk about the point and the y value or the x value. When I see a minus, it actually represents a positive y value in the point or a positive x value in the point. And when I see a plus, that means I put a negative in and it changed it to a plus. So it actually represents a negative, which can be a little confusing sometimes. So we're going to write an equation for each of the following lines described below. So our slope of 5 and our point 0.03. So plugging directly in here. So it's y minus our y value, 3, slope of 5, x minus our x value of 0. Now we have written an equation. Traditionally here, though, we do want to get this into slope-intercept form. That's kind of the exercise that we go through. So we're going to isolate that y value. And so I would distribute the 5x. Well, it's going to be times 0 over here, so that's nothing. So it's just going to be 5x. So I'm left with y minus 3 equals 5x, and I'm going to add 3 to go ahead and isolate that y value. And so y equals 5x plus 3. And the directions didn't specifically say to write it in slope-intercept form, which is what this is. But if you remember in this unit, that was kind of always where we got it to. All right, this one, slope of 1/2, and here's our point. So y minus my y value is 9. Slope, 1/2. x minus my x value. So this would be x minus negative 4. It's going to end up going plus plus. And that's what we were talking about, that you can rewrite this just as x plus 4 if you want. And to finish this out and actually get this into slope-intercept form, I do need to distribute. I'm going to leave this side alone. 1/2 times x is just 1/2 x, and 1/2 times 4 is just 2. When you multiply by a half, it just takes half of the number, so it's 2. So I'm going to add 9 to both sides to isolate my y. So y equals, I'm good, 1/2 x, and 2 plus 9 is 11. Okay, next step. We're going to go ahead and write an equation for a line just given 2 points. So we're doing the same thing, except up here we were given the slope, which just plugged right in. Now we're not given the slope, but we use the slope formula to go ahead and find the slope ourselves. So again, that's the y2 minus y1, x2 minus x1. So what we're going to do is subtract our y's, 5 minus 3, and then do negative 2 minus 2. 5 minus 3, negative 2 minus 2. And so my slope, remember this is my slope, equals 2 on top, negative 4 on the bottom. That's a negative 1/2 slope. Now I can go plug into my point slope equation, y minus y1 equals mx minus x1, and use this as my slope to go in for m. Now you have your choice. You can plug either one of these in for your x1 and y1. In this specific case, since these are both positive numbers, I'm going to go with that one. You can plug the negative 1 in. You got to be careful when you plug in that negative 2 for the x, that it's a plus 2. Either way, when you go ahead and simplify it all the way down to our slope-intercept form, they will be the same. Both of these points, once you put them in and simplify everything, they will be the same. So it doesn't matter which one you put in, but make your life easy. So y minus y1, so I'm going to use this one, 3. Slope is negative 1/2. X minus my x value. Now I can't pull a y from here and an x from here. They have to be the ordered pair. So if I put the 5 here, then I'd have to put the negative 2 here. But since I put the 3 here, then I can put the 2 right here. Let's go ahead and simplify this down. I'm going to distribute my negative 1/2 times the x. It just attaches. Negative times a negative. This becomes a plus, and half of 2 is 1. Finish it off by isolating, and we end up with y equals negative 1/2 x. Put these together, plus 4. All right, same thing for part B. First thing we got to do is find the slope. y2 minus y1, x2 minus x1. So on the top, 13 minus 4, those are our y values. 5 minus 2, those are our x values. So 13 minus 4 is 9, and 5 minus 2 is 3. Divide, and that's 3, so my slope is 3. So plugging in y minus. Now, both of these are just sitting there with positive numbers. Might as well use the smaller ones, but again, you can use either or. So I'm going to use this one. My y value is 4. Slope is 3. X minus my x value of 2. Simplify that out, so distribute. 3x minus 6, 3 times 2. And now isolate your y. So add the 4. So y equals 3x minus 2. Now for 6-7, when this video is being recorded, we were on distance learning for the coronavirus. So we don't all have graphing calculators, and so we skip this. So if this is now being used in a following year when we are in school, there'll be a separate video posted for 6-7 where you can complete it using your graphing calculator. So moving on to 6-8. Standard form of the equation of a line. So that is when your x and your y are on the same side. So the Hawkins family bought 3 sandwiches and 4 salads. They spent $36. So these are 2 different things, right? Sandwiches and salads. We don't know the cost, but if we knew the cost, there'd be 3 sandwiches times by 3, 4 salads times by 4. Add them together, we'd get 36. So how do we write that equation? So 3 times the number of sandwiches, which I'm going to call x, plus 4 times the number of salads, which I'm going to call y, equals $36. So since I'm using x and y, if if you wanted to use S and something else, but see, they're both S's, so it's kind of confusing. You got to go ahead and define your variables. So X is my sandwich, and Y is my salad. So we're going to go ahead and solve this to answer this question. If the sandwich cost $3.60, so sandwich was X, which means I can plug in $3.60 for X. And once I have this down to just one variable, like I do now, I can solve this for the other. So first thing I'm going to do is I'm going to multiply 3 times 360. That comes out to 1080. And now it's a simple equation to isolate the y. So minus 1080 on both sides, leaving me 4y. This comes out to $25.20. Divide by 4, and y equals $6.30. And on to, last but not least, 6.9, graphing linear inequalities. So instead of an equal sign, we have an inequality, a less than or a greater than. How do we show these on the graph? So we're first going to graph it like a line. Okay, and then we have to shade everything either less than or greater than that line. So starting here, this is our intercept, and this is our slope. Those help me graph. So y-intercept, where it hits the y-axis, is 4. So I start there. Slope is -3, which is -3 over 1. Negative means down. Down 3 over 1. Down 3 over 1. And when we draw these lines, we have to go back and remember that since this is either a less than or a greater than, or it could be equal to, we have to make sure we tell the difference by the line. So sometimes the line counts as part of the solution if it's equal to. If it's a less than or a greater than, we draw a dotted line. And what that signifies is that that line is not actually part of the solution. It is not included. Only everything less than this line. Now it always goes back to your y value. Here's our y value. The numbers less are down here. So our y value here is 4. So 3 and 2 and 1 and 0 and negative numbers, those are all the ones that are less. And so that shows you the region. Everything underneath of this line is part of it. If it said greater than, we'd shade up here. All right, and then the last one here. Intercept is -6, so that's where we start. Slope is +1/5. That's up 1, that's over 5. Up 1, over 5. Other direction, down 1, over 5, down 1, over 5. This now has an equals attached to the inequality, meaning the line is included. So we draw a solid line. It's open towards the y. That says greater than. So think of your y values. It's -6. Where are all the y values that are greater than -6? They're all up here. And so we're going to shade that entire region above the line.